Namaste, welcome back to Sitapragna channel, and you are watching AWS Cloud Projects for Beginner to Expert, and we are in the expert level right now, and that's why I'm having hard time understanding what they are explaining in these projects because this is season 7 and we are doing the projects as a machine learning engineer. So all the projects that we are going to do will be part of machine learning engineer role, and that's why I'm having hard time because I am not a machine learning engineer. I am a data engineer. So you might be asking, then why am I doing this? Well, I'm doing this not to explain you how this is done, but to show you in case if you are a machine learning engineering how it is done. Okay, I'm not going to explain you intricacies of machine learning models, how to write a model, etc. But I will show you how it is done by these guys and how those are, how do you put it? Those are being, executed or integrated with other services. And I'm planning to move my career towards AI and machine learning. And this won't be a starting point, but at least I'm going through this and I'm getting the or learning the terminology because that is important, and I'm learning few different things. I'm noting them down so that I can learn them theoretically because this video or this series is not for explaining you the basics of what machine learning and etc is. These are actual projects, okay, which means you should already have knowledge on the theoretical part of machine learning. Okay, if you are like me and if you just want to learn how this is being integrated, how certain things is executed, or if you want to get familiarized with the concepts, then watch along with me. Okay, so today we are going to do project number 84, which is about spy drones detection. So let's see, I think that person is right here. Let's find out what this project is about and how we can solve their problem. Hey, I am the mayor's head of security. I wanted to meet with you to discuss a serious situation. We are convinced that spy drones have infiltrated our airspace, stealing our information and wreaking havoc. Havoc. Nice to meet you. I have noticed a lot of drones flying around in the city, but they all seem friendly. What data do you have against these drones? We have been capturing flight data of all the drones in the sky. We have noticed that some drones have unusual flight characteristics, such as fast speeds with their transponders turned off, flying higher than normal, and exceeding our 20-minute flight duration limit. Maybe they are malfunctioning? That is one possibility, and I'm sure a small percentage are just malfunctioning drones, but we still want a method to predict which drones are spies so that we can get rid of them. Okay, sounds like the best way to tackle this problem is with machine learning. We can use an Amazon SageMaker Studio environment to set this up. Can you tell me more about the data you have collected? The data consists of drone ID, flight duration, maximum speed, maximum altitude, and whether the transponder is on or off. Our citizens have been volunteering to zap drones and determine if they are spies or not. So we also added that data to the data. Great. That means you have already classified and labeled the data. In this case, a label is the answer you are looking for, such as whether a drone is a spy or not. Because you have labeled data, we can use a supervised machine learning algorithm to solve a binary classification problem using that data. Binary classification problem? What is that? Yeah, exactly my question. In machine learning, a binary classification problem is one whose predictions fall into one of two categories, or binary, right? Either 0 or 1. In the case of drones, we can train an algorithm to detect patterns in the flight data that will predict true or false, 1 or 0 on whether the drone is a spy. I see where this is going. So you give some parameters and you already have some data, right? Which is your trained data. That's what they call it, which you already marked 0, 1. So you will feed that data to the model, then you will train it, then it will figure out, okay, when there are these parameters, then it is going to either 0 or 1. Then we will pass our test data and then we will see if it is awesome. We don't want to have to zap every drone we think is acting suspicious. How will this help us? After we train a machine learning model, we can use that model to deploy a SageMaker inference endpoint. Then we can send the endpoint real-time data, and it will respond by telling us if a particular drone is a spy or not. We will determine the best algorithm to use before we train a model. And then we can deploy a SageMaker endpoint and test the real-time response by using AWS Lambda. This solution sounds like it will save us time and money. Can we use a similar approach to detect vehicles in the city that are not environmentally friendly? We have the data for all vehicles that cross the main street. Absolutely. Will you help us set up and train a machine learning model to predict which drones are spies so that we can get rid of them? Of course, I'm going to. So, see, again, if you are haven't watching this from the video one for this season, I have zero background in machine learning. I'm just doing this and learning along with you guys whatever knowledge I have. So what I observed is first you will have you will create a model, right? And how do you train it? You will have some data. That data should already be labeled, right? For example, which one is spy, which one is not. That's how you are going to train your model by giving it already existing data that you already solved the problem. Okay, which you will have maybe on minimum data, right? Let's say if you have a million records, obviously you won't be having already solved it which one is a spy and not for the million. Maybe you will have it for 1000 or 2000. The more data you feed to the model, the more it will learn, but let's say 2000. Once you have it, then your model will be trained. But how will you know that whatever the model you have is giving you proper data results or not? For that reason, what you will do is you will have some test data again, right? Just to test it, you will have the answers, but again this will be different than your 2000. You won't take a subset of the 2000 and give it and try to test it, because obviously it is going to give you the right values because it is trained on that data. This will be like maybe 20 records that is not part of your trained data set but completely different one. Then you will feed it and you will check how much percentage it is actually spitting out the proper one. So you will have a threshold always. Above 90% is always good. If it is giving you above 90%, then you can say like whatever the model that is trained is good. Then you will put it in the production. That's what happened. I learned all this from these projects, just so you know. I am not taking any course yet. I have plans to, but not yet. So I think at least, I am happy with whatever I gathered from it. So let's accept it. All right, great. I look forward to using your solution to detect spy drones. So what are we going to do? We are going to use Studio IDE, which we already know how to do it. Deploy, train, test, and evaluate a supervised machine learning algorithm. Deploy a SageMaker inference endpoint, which we already did. Okay, so we are going to evaluate supervised machine learning algorithm. So let's click on start. Okay, let's click on our video concepts, and these are already some of them you watched it. So these we didn't watch them yet, and I highly recommend you to watch these. I am going to watch them offline because if you want to learn these, the best method is watch this because these are fun videos that explains you in and out of all these um, things that they are talking about in the title. Like for example, this one, machine learning, it explains you everything, not everything, but in a fun way using diagrams and etc. So watch them. I highly recommend you to watch them. And then where can you watch them? There will be a playlist that will pop up here. Click on it. Go search with these titles. And yeah, once you watch them, come back to this project and we watch the rest of the project. Okay, let's look at the diagram steps for this project. This solution uses SageMaker to deploy a supervised machine learning model. The model will be trained using a binary classification algorithm. The binary classification algorithm separates the input into two discrete mutually exclusive classes based on their attributes. Supervised learning algorithms require datasets that contain both features and labels, input and output. Amazon SageMaker Studio provides the tools to load a Jupyter notebook and download the dataset from S3. SageMaker provides features to monitor and manage the training and validation of the machine learning model. After the machine learning model is trained, deploy it to a SageMaker inference endpoint. SageMaker inference endpoints support real-time predictions that require low latency. These endpoints can be configured to support autoscaling. AWS Lambda can be used to test that the inference endpoint is correctly predicting results. You can use SageMaker to quickly retrain machine learning models and deploy more robust inference endpoints depending on changing datasets or increased workload demands. Basically, we are doing pretty much everything other than training a supervised machine learning model. So let's see what we are going to do as part of practice labs as well as DIY. Download and walk through a Jupyter notebook stored in S3, which we have done. Train and evaluate the XGBOOST supervised learning algorithm. That we didn't. Deploy an Amazon SageMaker inference endpoint. Test it, which we have done. As part of DIY, repeat the lab using a different data set. Deploy a new SageMaker inference. Reconfigure. Got it. Let's start the lab. Nothing to download. Let's click next. Let's go to S3. Spy drones lab, and it has that notebook XGBoost Island Detect Spy drones notebook. Copy the URI. Let's go to SageMaker and Studio. They already created it for us, so let's open it. And then let's go to the Studio Classic. Then open it. Again, same steps, new file, new terminal. And the notebook is already here. Is it? No, it's not. Okay. That's why we will download it from S3. How are we doing it? By using the AWS CLI copy command. Once we then we will open it and then pick the image and the kernel and everything remains same. Select. Now we have it. So all we have to do is go through that, which we will do. I don't think we have to. Let's go next, next, next. Run, review, run, review, which we will. Okay, okay, okay. Yeah, I'm skipping this because we can read the notes from here. We don't have to read it again here. Okay, once I think we are at the end of the notebook, go log out. Why are we logging out? You are automatically returned to the node SageMaker console if you log out. Okay. Then let's go to inference endpoints, click it and let's copy that because Lambda needs it. We are doing this. It's already like I think third or fourth project we are doing the same thing. And code, we review the code later on. Then let's copy. I think they already commented out the code for us. Let's copy it. Island friendly user, doesn't matter what you give the event, delete it, and then we will pass that data here as the input. Configure, edit, replace, then execute it. Once you execute it, I guess we will get the output. But that output is supposed to be sent to what? The SageMaker. I think pretty much that's about this. So let's go ahead and finish it quickly. I don't know how long that notebook execution takes because that's where most of our time is spent. So let's go to S3. Sky drones. I mean, those are just data files. We don't have to copy anything. We just have to, sorry, we have to copy the URI, not. So that's about it here. So let's click. Click on Studio. It's already created for us. Open it. Studio Classic. This is already created and running for us. Let's open it. This is the Jupyter Lab. Okay, here we are. So let's go to File, New, Terminal. Okay. And if I click on the folder, you see there is nothing, right? So for that reason, let's go ahead and bring in that notebook, S3 copy, and the URI paste it. And where are we copying it to? This particular directory. And it will pop up here if I click one more time on this one, because that just refreshes. So right click, open it. Everything is default, just select that. Then it is going to, wow, that was fast. Instantly. Okay, so let's go through here. In predicting island-friendly cars and spy drones with XGBoost. XGBoost is the supervised algorithm that we are going to use. Using gradient boosted trees to predict cars that low impact to the island's fragile ecosystem. We will be using this same notebook for the DIY portion of the lab by using small changes to the files and referenced frames. Wow, okay. This notebook has been adapted from an AWS blog post. Island ecosystems are fragile, and to reduce the impact that some automobiles have, we need a way to predict which automobiles are island friendly. By giving island citizens the ability to input their automobile data, we can give them the opportunity to steer away from automobiles that may not be healthy to the environment, cause crowding, and deplete resources. This notebook describes using machine learning for the automated identification of island-friendly vehicles. Machine learning models rarely give perfect predictions though. So this notebook is also about how to incorporate the relative costs of prediction mistakes when determining the financial outcome of using machine learning. This notebook was created and tested on a M4X large notebook instance. Let's start by updating the required packages, that is SageMaker Python SDK, Pandas and NumPy, and specifying S3 bucket and prefix that you want to use for training and model data. Let's go ahead and see that. Okay, when anytime you have this exclamation mark, that will be executed on the Linux system, and we are running pip install. We are upgrading the pip. We are installing SageMaker, Pandas, Num, Matplotlib. If it is already installed, then it will be updated. Okay, it is going to download all those. Okay, while it is doing that, let's go ahead and look at this. Okay, let it finish it. Did it finish? No, it's still running. Okay, the next cell, you are importing SageMaker board 3 RE into this particular code, and we are creating a session, SageMaker session, and then okay, I guess that's okay. I think that should be fine. Yeah, it is done. And lab account, you are getting from the you are getting, I think this is what temporary credentials it's called. What is it called? I forgot. Bucket lab account. Where are we getting these from? Print. We are printing the bucket, default bucket. Okay, default bucket. Okay, that's the account, lab account. It is going to append to this. That's prefix lab x boost island friendly. Okay, now we are getting the role. If I run this, okay, default bucket, IAM role, it's printing all of those things. Okay, that is nice. Next, we will import the Python libraries we will need for the remainder of this exercise. So let's run that. And then the data. The data for this model comes from University of California, Irvine Machine Learning Repository, and originally used for the purposes of assigning insurance risk scores to vehicles. We have modified the dataset slightly for our purposes. We can use this historical information to construct an ML model to predict island-friendly vehicles using a process called training. After training the model, we can pass the profile information of an arbitrary car. Only they are giving one car, okay? The same profile information that we use to train the model to the model and have the model predict whether this vehicle is island friendly or not. Of course, we expect the model to make mistakes after all. Predicting the future is tricky business, but I will also show how to deal with prediction errors. Let's download and read that dataset is now in now. Comment out the line for download of island autos.csv and uncomment the line for drone. Okay. Okay, this is for the DIY. For DIY section, comment out. Oh, okay. What? Okay, this is not DIY, so we are supposed to have it that. Okay. Okay, that is for the DIY. Never mind. Okay, I need to run it. This is just again copying into this particular directory, right? Whichever one the working directory is for this one. The data scientist that provided the data did some cleanup and any previously empty or erroneous values have been populated with a question mark. We will import the data using the NA values parameter that references a list of known missing values. As you work through the data and see other types of missing values, you can add them to the list below. Okay, let's run this one. So missing values is question mark right now. If we see anything later on, we can add it. And we are reading using pandas. Maximum column size is the limit, and then it is printing it. You can see the data here. Island friendly? Yes, yes, no, yes, yes, yes. Fuel type, aspiration, and other columns. You can see that. Dealing with missing data. The important imported data frame above has 205 rows. The below code creates a new data frame and prints out all rows with at least one attribute marked as none. As you can see, only a few rows have empty values. Yeah, oh, this is not empty. This is just telling you there is more data. So let's run this. Yeah, you see price. Some have empty values. And even this one. Yeah. Okay, let's run this one as well. What is this doing? It is calculating the mean price and then it is printing the vehicle, the mean vehicle price is that, and then it is filling empty values with the main. Okay, that is one way to do it, right? Instead of having none for the price, it is filling with the main value, whatever that is. The mean is 13,194, so wherever it's none, it is going to fill it with that one. Okay, nice. Now that we have done a first pass at cleaning up the data, let's review more details about it. By modern standards, it's a relatively small dataset with less than 200 records, where each record has 16 attributes. The attributes are make of the car, fuel type, aspiration, turbo versus standard, number of rows, body style, drive. I think these are self-explanatory. I don't have to explain it. The last attribute, island friendly, is known as the target attribute. The attribute that we want the machine learning model to predict. Because the target attribute is binary, our model will be performing binary prediction, also known as binary classification. Let's begin exploring the data. Other fields in the drone flights data set are drone ID, the target attribute for the drone flights data set is spy. What? Why is it a question mark though? Okay, this is they are explaining about the drone. We don't want to learn about that right now. So for column in machine learning, select data types, include object columns, display. Okay, we are cross tab, index, ML data, column. What are they exactly doing here? Okay, they are renaming them observations, and then the column 0 index column. What is the column? Okay, for column in include object columns. Display cross tab. So they are selecting the cars, but what is observations? Is that a column? No, that is not a column. But where did we get that? Histograms for each numeric feature. Oh, okay. So for each one of them, not just for everything. This is the make each column. Okay. It's just they are getting the histogram percentage of these two for each column type. So this, if you add all of them, it will account for one. Island friendly. Wow, just that is doing all this. Okay, that's that. Display, describe. Okay, this is the matplotlib which is drawing that histogram. How to draw this? We have done that. Okay. I think describe is printing this. Count, mean, standard, median, minimum, maximum. What is it called? First quartile, third quartile. I don't know what this is called. And this is the matlab. Oh, sorry, matplotlib. Lib. Island friendly. Most of them are. Curb weight, horsepower, peak RPM, city MPG, highway MPG, and prices. We can see immediately that city MPG is quite evenly distributed. You can see that. I don't know if it's considered as quite evenly. If that is quite evenly, even this is, right? I see like there is two peaks here. Highway MPG statistics are very similar to city MPG. Yeah, right. So we will drop highway MPG as it seems redundant. Most of the numeric features are surprisingly nicely distributed, with many showing bell-like Gaussianity. Bell-like Gaussianity. Bell. Peak RPM being a, I think this one, yeah, notable exception. So we will drop that feature from the data as well. Okay, so that's how we will figure out, I guess. So here we are dropping these two columns. Next, okay, there is, what is this? Okay, this is for the drone. Okay. Next, let's look at the relationship between each of the features and our target variable. Okay. And here we are doing something similar, but we are taking island friendly column. Let's run it. Okay. Okay. Again, island friendly, and we are taking make, and out of it, which one is friendly, which one is not on each of the make. Okay, looks like Volvo is all friendly. Is that it? But this is just okay. Everything considered, okay. Even Isuzu is all friendly, Jaguar is all friendly, Chevy is what? None of them is friendly. BMW friendly, or all costly cars are like friendly. Mercury, I don't know what that is. Saab. And aspiration, that drive wheels, each one of them. Now curb weight, this is for friendly, this is not friendly. Okay, they're not explaining anything about that or what? So these are what display again, plotting scatter matrix. Island friendly. Cor- Interesting. This one line did all this. Wow. Let's shape. Now that we have cleaned up our data sets, let's determine which algorithm to use. How? You are not explaining any of this. Let's see. Did they explain anything here? I don't think so. I didn't see any graphs. Did you guys? I didn't see any. Okay, here we see. Okay. That just say telling review. Let's see if they explain anything here. Oh, they didn't. Matplotlib is a plotting library for the Python programming language, and it's that's it. Distribution of seriously. That's all you have to say for this. As a data scientist, you would review the output to analyze any correlations between the target variable and each individual feature. Okay, I would, but explain me. I'm not a data scientist. I think that's about that. That's fine. Let's go ahead with this. As mentioned above, there appears to be some variables where both high and low values are predictive of non-island friendly vehicles. In order to accommodate this in an algorithm like linear regression, we would need to generate polynomial or bucketed terms. Instead, let's attempt to model this problem using gradient boosted trees. Amazon SageMaker provides an XGBoost, so this is called gradient boosted container that we can use to train in a managed distributed setting and then host as a real-time prediction endpoint. XGBoost uses gradient boosted trees which naturally account for non-linear relationship between features and the target variable as well as accommodating complex interactions between features. Amazon SageMaker XGBoost can train on data in either CSV or libsvm format. For example, we will stick with CSV. It should have the predictor variable in the first column, not have a header row. But first, let's convert our categorical features into numerical features. Okay, let's get dummies. What does that do? Oh, everything changed to numbers. Make, oh, they changed. Okay, it's like pivoting. They changed all the categorical values as columns and then they denoted with values. All right. Okay. What is the function? Get dummies. And now let's split the data into training, validation, test sets. This will help prevent us from overfitting the model and allow us to test the model's accuracy on data it hasn't already seen. Okay, if you look at this, train data, we are passing train CSV, validation data, validation CSV. Now we will upload these files to S3. Moving on to training, first we will need to specify the locations of XGBoost algorithm containers. Okay, where is it? Image URIs retrieve XGBoost. That's the name. Okay, we are getting the latest display container. We have done this for other models. Then because we are training with CSV file format, we will create training input S that our training function can use as a pointer to the files in S3. Okay, training input, and we are saying it's S3 data. This train, this is like parameters you are passing from here. Bucket and prefix. Content type is CSV. Now we can specify a few parameters like what type of training instances we would like to use and how many, as well as our XGBoost hyperparameters. A few key hyperparameters are max depth, controls how deep each tree within the algorithm can be built. Deeper trees can lead to better fit, but are more computationally expensive and can lead to overfitting. There is typically some trade-off in model performance that needs to be explored between numerous shallow trees and a smaller number of deeper trees. Subsample controls sampling of the training data. This technique can help reduce overfitting. Too low can also starve the model of data. Num round controls the number of boosting rounds. ETA controls how aggressive each round of boosting is. Larger values lead to more conservative boosting. Gamma controls how aggressively trees are grown. Wow, this terminology. I think I need to get used to that. More details on XGBoost hyperparameters can be found on the GitHub. Okay, let's click and execute this. Estimator. It's taking container, role, instance count, instance type, output path, SageMaker session. Hyperparameters. Max depth, whatever we have just learned. And is it still running? Yeah, it is still running. Fit train validation. Now that we have trained the algorithm, let's create a model and deploy it to a hosted endpoint. And we know this function, deploy, how many? One. What is the instance of that? Serializer is the CSV serializer. Okay. Predictor, predictor dot predict. That's what we will use later on, I guess, somewhere. Yeah. Okay. Let it run, and once it finishes, then I guess we can come and do this, because without it runs, we don't have this value. Okay, it is done. All right, let me scroll down. Okay, seconds it took that long. Training job complete. Let's go ahead and click that one. And not sure how long that is going to take. Now that we have a hosted endpoint running, we can make real-time predictions from our models very easily, simply by making a post request. But first we will need to set up serializers and deserializers for passing our test data, numpy arrays to the model behind the endpoint. Now we will use a simple function to loop over our test data set, split it into mini batches of rows, convert those mini batches to CSV string payloads, retrieve mini batch predictions by invoking the XGBoost endpoint, collect predictions, and convert from the CSV output our model provides into a numpy array. Wow. Okay. Let's see how we are going to do all that in a function. The function takes data and rows equals to 50. We are splitting the array split data dot shape float rows plus 1. I don't know what will that give. Predictions for array in split array. We are extracting each split. Predictions equals to whatever that is. We are joining and preparing predictions. Okay, let's see how it is going to look here. Test data predictions is we are passing the data here to numpy. Okay, that is still running, so I can I use this XGB predictor? Am I using it here? I don't think so. Yeah, I am using. Okay, never mind. Let's wait for that to be done. All right, the execution is done. Let's go ahead and run this one now. And that is done. Let's see the values, how they look. Okay, that is the test data. Okay, this is all the test data, and this is the values that are returned, right? If I see it properly, that's the test data, and these are the predictions for them. There are many ways to compare the performance of a machine learning model, but let's start by simply by comparing actual to predicted values. In this case, we are simply predicting whether the vehicle is island friendly or not, which produces simple confusion matrix, yeah, named appropriately. Cross tab test data, and then we are getting from the predictions actual predictions. This is actuals, that is predictions. What? Hold on a minute. Of the 20 vehicles, we have correctly predicted 19 of them. Okay, true positives. And we incorrectly predicted one vehicle to be island friendly. Oh, okay, so these 11 good. We didn't predict anything that. Okay, this is 8 good. Okay, that is the only one that is predicted as island friendly when it is not. Ended up being so, which is known as false positive. There are no false negatives in our testing. An important point here is that because of the np.round function above, we are using a simple threshold of zero point 0.5. Our predictions from XGBoost come out as continuous values between 0 and 1, and we force them into the binary values that we began with. To get a rough intuition here, let's look at the continuous valuations of our predictions. That's it. Where did the remaining go? Okay, not that. What happened? Is this the end of it? Okay, that is weird. Let's go. I think that's about it. They didn't even explain it. Oh, that's fine. Histograms again. I think these are like ones like point 0.1. I think we changed that to 0 and these 1 and this is the 1. It's supposed to go into here, but I guess it went here. False positive. All right, so let's go ahead. I think we can go file log out. Do we want to log out? I think I'm fine with it. I can still go to this window, deployments, endpoints. Okay, let it load. Okay, that's taking time. I can go here as well. Inference, endpoints. I can copy the name. Let's open the Lambda. Endpoint test functioning. Configuration. Let's change this. I don't know if it will take more than 1 minute, but let's give that. Save it. I didn't see how long they gave it. Sorry, configuration, environment variables, edit it, paste that, save it, lambda. Okay, I don't know why I went there. Code. So we are getting the code and then we are starting SageMaker, then loading using JSON, the dumps event, whatever we are getting. So they asked us to use this one as the input data for this particular example. We are looping how many? 3 loops? 0, 1, 2. Yeah, because we have, I guess, 3 records. Payload string I. So we are converting each one. Hold on a minute. No. String I, we are converting this into string. Then we are appending data. So technically we are preparing this. Then print payload, which will print data 0, 1, 2. Endpoint response. Payload is the payload. Oh, sorry. Data is our actual data in here. We are reading these. So for the key, we are preparing that and then we are reading their data and sending it respectively. And if it is greater than 0.1, we are just appending it, else we are appending to the value 0. So let's run it. So in order to test it, we need to create event and let's put this one. It is done. And you can see island friendly, not friendly. Okay, that's the output we got. So if we check it, does it say anything to us? I don't think so. two island friendly vehicles and one non-friendly, which is what I guess we got. So it is working as expected. That's the practice lab we did. So they thought here how to create the supervised learning model using XGBoost. Let's go ahead and do the DIY, which is going to be similar. Repeat the lab, but using a different set. Deploy a new SageMaker inference endpoint. I guess we can do that. So first of all, if we go here, we don't have to run that. It's already there. Okay, we don't have to run this one as well. I think we are fine with this one. This one is fine. Okay, here we go. Okay, here. So this is the place where we are uploading our file or downloading our file, which is the drone flights. So let's run this one, which is downloaded. Now we have to identify data, right? If there is proper data, missing values data, etc. So let's go ahead and what are we supposed to do? Instead of islands, let's replace it with drones because that is what. Even in here, I think there are question marks, etc. They should have showed us, but that's fine. Let's run it. Now you can see our drone data. And now if we go ahead and if we run this, it will show only transponder looks like having all the nonce. And let's go and change here. I mean, this one doesn't have a price, does it? It doesn't. Okay, so I don't think we have to run this one because we are fine. I think we can ignore this. We don't need that. This is the mean ML data, ML data. We don't have to give it. I think our ML data is fine. But aren't we replacing the transponder? Comment out this line for DIY. Drop any rows that okay. So we will comment this out completely for the because we don't have the price, but we are dropping the remaining columns that might have the data. So it changed to ones and zeros. I think that's what we are doing here. Drop NA axis 0, how blah blah blah. I think all those. So here we have 196. Here we have 203 or something. 4. We are dropping them. And this is about the drone flight data. We have drone ID, flight duration, transponder on or off, maximum altitude, maximum speed. And I think we can use this one and execute it for the same. Okay, you got the count and all that. Why? Because any value that is missing, maybe for transponder, right, we can just put the its mean in place of missing value. So spies, either it is 0 or 1. I don't think there is anything that's there. I mean, obviously this is our value that we want to predict it. Drone ID, flight duration, transponder. I think transponder, it's either on or off. Pretty much that's about it. So we don't have to run this one because these two columns are for the other one. This is for the DIY though. We are dropping drone ID because we don't need it for anything, right? Drone ID is just a unique column which is used to identify that. Okay, so wherever we see, I think island friendly, we are going to replace that with spy. And why go through all this hassle? They should have given us a separate one. That's fine. Okay, let's run it. I think we can see the graph flight duration, transponder. I think this is for friendly, not friendly. I mean, they look, I mean, this is what there is a term for it. Right, left, it's called something, I forgot about it. Right lenient, left lenient, something like that. Yeah, same thing here. This is like uniform and correlation. Okay, this looks now okay. Yeah, negative. If somebody can explain me this, that would be awesome. Okay, this we have already read through. Now let's run this get dummies and convert all the columns into zeros and ones and train data and put. Okay, hold on a minute. To CSV header train data. Okay, here we go. We are splitting. Okay, we are splitting these number of records into these data sets, some percentage of them at least, and then we are uploading them to S3 again. Okay, here we are retrieving that which we already did, but let's do it again anyways. Should I change anything here? I think we are good, but it is going to take some time for this one because we have changed our data, right? So obviously we need to rerun this one. So let's give it some time and I will be back by once it is run. Okay, it is done. Estimator fit, it's all done. Now that we have trained the algorithm, let's create a model and deploy it to a hosted endpoint. Okay, algorithm is done. Let's deploy it. I think it is going to take, how long did it take? 5, 6 minutes, I don't remember. But it is going to take some time again. So let's be right back. All right. Okay, there is lots and lots of waiting here. That's okay. I wanted to finish lot of these projects because there is nothing much I have going on here, right? It's pretty much they are giving everything away here. All right, let's go ahead and run this one. I exist here just to trigger this. That's fine. At least I get to know the steps, even though I don't understand most of them. And I think we are done. This last one gives us our values. And I think this didn't, wow, it's 100% worked. Oh, not for this. For this one, I think for the DIY, we matched all of them. 1, 1, 13, 0, 0, 7, none of those. No false, trues, false. Positive, true positives are true negatives. So we don't have any of that, which is nice, right? Cool. Oh, okay, hold on. I ran this predictions. Where is it getting the predictions from? Okay, that's fine. I think it worked. What else they want us to do? Yeah, they want us to reconfigure. So which one is that? 19. So copy this. Lambda configurations, edit. Same thing that they asked in the previous video as well on the previous project. So we need to get the endpoint, which is this one. Validate. That should work because we have done nothing. They have provided us with everything. Yeah. Okay. Yeah, leave. I don't want that. Okay, so that's about this project. At least we got to see XGBoost supervised algorithm, supervised machine learning algorithm. Okay. I think the takeaway for me, as I mentioned previously, is all these words, terminology, and different algorithms so that I can make a note of all this and then go ahead and learn them. Great job. Now choose your reward. I think I will go with this one, right? Because that is one way of learning different things. because even though you will have a number of things when you are learning something, you might not be using all of them in your at your work because this learning is for the work, right? So when you look at the projects, then make a note of the things that they are actually using, etc. Go learn them. Once you actually get the job and start working, then you will learn more things. But in order to get there, I don't think you have to sit there and study 100%. All you need is the things that they are actually using. I think that should be good enough. Let's go ahead and zap some drones. This is a quiz time, by the way. Let's see who is going to win. Which classification machine learning problems are supervised learning algorithms good at solving? I think binary, because that's what we did. No? Already one wrong. Which popular Python libraries are used to prepare and explore machine learning training data? Two? Maybe I was supposed to select a two there. Maybe that's why. Okay. And by the way, pause the video, answer it, and then check the answer. Don't cheat. Okay, 1-1, three more to go. An unsupervised learning algorithm requires a training data set that has both features and labels. I don't think so. I think the supervised requires labels. Unsupervised, I don't think it requires labels. 2-1. So far, not that good. Let's see if I can make the other two. Which type of machine learning component is XGBOOST? It's an algorithm. Yep, yep. We just did it. 3-1 and the final one. Or did I just miss it? What are the three types of machine learning algorithms? I know supervised, unsupervised. I don't know which one. Okay, I will go with reinforcement learning. Or, hold on a minute. Reinforcement? Maybe enforced. I will go with that. Let's see. Come on. Can I go back? Anyways, wrong. 3-2. So I got three right, two wrong. Put that in the comments, my score and your score, and let's see who won. Most probably you guys have won. Okay, but I want to know it. So leave a comment, like, subscribe, and you can even become a member to support this channel. Thank you very much for hanging out here. See you in the next video. Thanks a lot. Have a great day. Bye. Peace out.